Alright, so in this video, we're going to be taking a look at two examples from the AMC 10A. One of them is from the 2016 AMC 10A, and the other one is from the 2019 AMC 12A and the AMC 10A, so it was one of the problems that are common to both tests. And we're going to be looking at both of them, and both of them are problems where like radii, tangents, etc. So tangents, circles, radii, that sort of problems. So basically circular geometry is what we're going to be looking at today. So let's get started. So this one comes from the 2015 or 2016 AMC 10A, problem 15. And it's the problem states that 7 cookies of radius 1 inch are cut from the circle of cookie dough as shown. Neighboring cookies are tangent, and all except the center cookie are tangent to the edge of the dough. So basically, all of these cookies touch, or they're tangent basically, and the center cookie is not tangent to the outer circle, and all of these smaller circles are internally tangent to the larger circle. The leftover scrap is reshaped, so the leftover scrap is basically we're cutting these circles out of this big circle, and what's left over is like these pieces over here. So this, basically all of those pieces is what we're calling the leftovers, sort of. And it's reshaped to form another cookie of the same thickness. So many people might get confused when it says the same thickness. Basically, it's saying it's like if we consider a cookie like a cylinder, we basically don't even have to worry about thickness. We can just consider it like a 2D circle, because thickness doesn't really matter. But assuming it's a cylinder, that cylinder has the same height. So we don't care about thickness. So thickness doesn't really matter here. That's what it's telling us. What is the radius in inches of the scrap cookie? So basically, the first thing we're going to start off by doing is connecting the centers, since that's what you do when you have, anytime you see a problem like this, just connect the centers, and that's how you solve it. So we first off need the radius of the big circle. So for the radius of the big circle, you want like the midpoints right here. So then you can draw radii, and this will be the radius. So each of these cookies have radius 1 inch. So that means this is one, this is one, this is one. So if I draw this radius in here, and I can do the same over here, 1, this is 1, this is 1, so this is 1, this is 1, and that's 1. So this total thing has a diameter of 6, which means the radius of 3. We can also know that this is just the center of a circle, so this is 1, 2, 3. So we have a radius of 3, so our area is pi times 3 squared, which is 9 pi. So our area of the big circle is 9 pi. And 7 cookies are radius 1 inch, so each of these has radius 1 inch. So this is 1, this is 1, this is 1, this is 1, and all these are 1, of course. So basically, it's a unit circle, so pi times 1 squared is pi, so a unit circle is area pi. You don't really have to memorize this, but it's just like if you use the area of a circle formula, it's pi times r squared, pi times 1 squared, pi. And there's 7 of them, so it's minus 7 pi is 2 pi. So that means the area of these leftover regions, these regions that don't lie in any of these 7 circles, is 2 pi. And we want the radius of the scrap cookie. So the scrap cookie, I said before, we don't care about thickness, so if we even if it's a cylinder, we can take a cross section of it. And if its area is 2, that means its radius is root 2 pi. It means radius is root 2, since pi times root 2 squared is 2 pi. So that means the radius is root 2. That's what we're looking for. So that means the answer is the square root of 2. And that's the solution to this problem. Okay, so now we're going to take a look at another example. So this one is from the 2019 AMC 10A. It's also from the 12A. So that's basically it. You can just So basically, the problem is very similar. The figure below shows 13 circles of radius 1 within a larger circle. So here we have 13 circles, but again we have unit circles, so we can mark them having radius 1, but we're not going to draw the radii yet. All intersections occur at points of tangency. What is the area of the region shaded in the figure, inside the larger circle, but outside all the circles of radius 1? So they've already they shaded the region that we want to find. That's like an area we want to find. So I think the biggest mistake here is people will go like this. And this is what I mean by that. They'll start at the center of this circle. And they're going to go down like this. And draw a diameter. They'll, of course, include that region. They're going to draw a diameter. They're going to say, this is radius 1, so diameter 2. Here, well, this is basically here, down here. This is diameter 2, diameter 2, diameter 2, diameter 2, 1, 2, 3, 4, 5. 2 times 5 is 10. And then they're wrong, because it's not even an answer choice. So, basically, the reason this is wrong is, let's first draw the radii, right? I see a lot of things. I see a hexagon. I see hexagon if I connect these centers. Again, the strategy is the same. Connect the centers. You want to be careful in these types of problems. And there's sort of like a step plan you can do to solve these. I see a regular hexagon, but I also see an equilateral triangle. And I like equilateral triangles because equilateral triangles are easy to find the altitude. So I'm going to draw this equilateral triangle up here. And once again, these all have radius 1. The circle, the smaller circles. So we can draw that. We also have another equilateral triangle down here, if you see this. But we're going to start off with just one. And all of these, so this goes up here, it has radius 1. This has radius 1 up here. So we have an equilateral triangle. Now we can find the side length since we know the radius of each circle. So we know this is 1. This has radius 1, diameter 2, 1, 2, 2, 1, 1, 2, 2. And that's 1. So 2 plus 2 is 4, 5, 6. So it's an equilateral triangle with the side lengths being 6. So if we consider this an equilateral triangle. And it's easy to find the altitude, so if I just drop an altitude, I have a right triangle, a 30, 60, 90 right triangle, which whenever I have an equilateral or an isosceles triangle, when I draw the altitude, it's a perpendicular bisector to the base. It's down here, so 30, 60, 90 triangle, this is opposite of the 60-degree angle, so it's 3 root 3. So now we know that this is 3 root 3. This all the way up here. Now all we need to do is find this. And once again, connecting the centers is important. We have this. So we could form another equilateral triangle to figure out this remaining height, right? This basically, this remaining height down here. If I sketch that in right, there we go. Right, so we have this equilateral triangle down here. And it has, this is radius 1, radius 1, radius 1, radius 1. So this has equilateral triangle with radius, with side length 2 formed by the radii of those circles. And once again, it's pretty easy to find the height or altitude. So that's root 3. So we have, this is 3 root 3, and this is root 3. But we have these radii over here. This is 1, and on top we have, that is 1. So we have 1 plus 1 is 2. And we have 3 root 3 over here, plus root 3 plus 2. And this is like 1 root 3, so it's 4 root 3 plus 2. Which yields 4 root 3 plus 2. And that's the diameter of a circle. We figure out the diameter, we want the radius. So to find the radius, we just divide by 2. And you get 2 root 3 plus 1. And now we can find the area of the big circle, which is pi times r squared, which r is this over here. So now I can square this, and we can square the binomial normally. So 2 root 3 squared, 2 squared is 4, square root of 3 squared is 3, 4 times 3 is 12. So it's 4 root 3 plus, then it's just 1, which is 12 plus 1 is 13, plus 4 root 3. But remember, we didn't multiply this entire thing by pi, since it's pi r squared. So this is pi, this is 4 pi root 3. And then that's a big circle. And then lastly, we just subtract off the combined area of these white regions. So the white regions are 13. There's 13 circles of radius 1, which means there's 13 unit circles, which means they have a combined area of 13 pi. And simply just cross out, and we're left with 4 pi root 3 is our answer. So we can just box this. And 4 pi root 3. Okay, here we go. That's choice A. Is 4 pi root 3. Simple, nice, simple answer. And that's basically the solution to the 2019 AMC 12A problem number 10 / AMC 2019 AMC 10A problem number 16, and the other one that I just showed previously.